All right, cool. I think we're live, right? Uh, okay. Let's see what this one is. Specific context of text, Dartmouth, AI model for mental disorders, using conversations on Reddit. Oh shit! All right. The specific context is they focus on emotions rather than the specific content of social media text. Okay, so then I'm actually really curious. How do they tell? How do they train the AI to say which people have mental disorders and which ones don't? Whew. Different emotional disorders have its own signature pattern of emotional transitions. Is there a code? Is there code here for this? Um, and a user can compare it to established signatures of emotional. Or I see. They look for a pattern of emotion in the user posts, and then they compare it to known mental disorders for those posts. Interesting. Uh, yeah, I wonder if they have like code that we can play with for this. And how accurate is this even? Uh, let me zoom it up. I'm not sure. Oh, okay. There's a class. Yeah, it's a classification model between four different emotions. Uh, okay, so they don't actually have the code here, but yeah, they don't actually have the code here. This kind of sucks, but mm, all right. What else? What else we got? Leaked no leaked stolen NVIDIA certification can sign Windows malware. Oof. Okay, testing without mocks. I want to see this one. They interact with mock objects. Yep. So for those who don't know, mock objects are basically just they contain a shell or outer contract of the code, but they don't contain any of the inner workings. So when you want to mock an object, it's up to you to define. Hey, when this function is called, you return this value. So the mockup is just a shell with no underlying implementation. That's it. Okay, so then pattern. When programmers use test-driven development, the code they interact with, other parts of the system are being tested. Yes, to test those interactions to prevent double interference with their tests. Programmers often use mock objects or uh, other test doubles. Yes, however, this approach requires additional integration tests to ensure that the system works as a whole. This pattern language describes a way of testing object-oriented code without mocks, but it has its own trade-offs. All right. What the heck is pattern language? I have no idea what this means. What happened to my voice? Oh, is there something wrong with my voice, dude? I don't know, man. Maybe it's just my morning voice, dude. Yeah, I think it's just my morning voice. You know, you sound a little bit different in the morning compared to like, um, yeah. I guess it's just really my morning voice. Like it hasn't had a chance to really warm up yet. Hey, Bucket Sword, what's up? Test specific production code. Some code needed for the test is written as tested production code, particularly infrastructure classes. It requires extra time to write and read. Yeah. Handwritten stub code. Some third party infrastructure code has to be mimicked with handwritten stub code. Okay, sure. Sociable tests, although tests are written to focus on specific concepts. Units under test execute code in their dependencies. Okay, this can result in multiple tests failing, and it's not a silver bullet. Okay, I still don't know exactly how he's doing this. I'm guessing that I have to watch this test without mocks. Yeah, I'm guessing I have to watch this in order to get this content. I guess it's just like a little bit too outside my thinking and knowledge, so I'm not quite sure. Eager to hear this session before you sleep? Okay, we're gonna go for like 2 hours, man. So I mean, this will be on YouTube, so you can watch the replay after. Yeah, I appreciate the participation and the support, guys. Thanks. We're gonna start in about 8 minutes, by the way. So if you guys have any questions or comments or whatever, let me know. I'll be happy to answer them before we get started. Hey, Goldfish. Hey, thanks for supporting me. Let's see, what else? Cyber criminals who breached NVIDIA issue one of the most unusual demands. Okay, let's see what it issued. Okay, crown jewel source code release. Data extortionist stole 1 terabyte of NVIDIA. Delivered the most unusual. Allow NVIDIA's graphics card to mine crypto faster. Okay. Okay, y'all can calm the fuck down now. Oh, no problem. Thanks for the channel. Yeah, you're welcome, man. Ransomware calling itself Lapis claimed that they hacked into NVIDIA's corporate network, stole more than 1 terabyte of data, and they published 1 tranche of leaked files, includes the name and cryptographic hashes for 7,100 of chipmakers' employees. Okay. Mining and gaming community. We want NVIDIA to push an update for all 30 series firmware to remove every LHR limitation known to leak a hardware folder. If they remove the light hash rate, we forget about the hardware folder. We both know LHR impacts mining and gaming. Yeah, I mean, I don't want fucking random people to just buy up all the graphics card to mine Ethereum. The fuck? They want NVIDIA to commit to making its GPU drivers completely open source. Oh, no. They're basically, they're planning on frying these graphics cards to mine Bitcoin. Holy fuck. That's actually... Well, they literally hacked and ransomware just to help them mine Bitcoin. Wow, what the fuck? Yeah, no, thank you, man. Voice lessons, how coaches get in athletes' heads. I'm very curious, because I have never done any of this crap, or voice lessons or whatever, but let's see what they have to say. Stood by the ice, people call him Quad King. Okay, quadruple. He did a quadruple, sure. Correct flaws during practice, yeah. My head needs to be here. He kept his thoughts empty as he began his routine, focused on the cues. With 1 jump to go, remember, feel like connected. We did our job, alright. Next thing that jumps are getting dicey. A 150-pound man lands a quad with a force perhaps 10 times his body weight. And he has to make them precise, do 80 of them per day. That you want to do a 3rd jump. We completed the program, we practiced. Heard the words, but at the moment something refocused. He suddenly felt calm. Okay. He's talking about ice skating, blah, 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 telling a story of, like, being connected with his coach. So the question is, what exactly is he talking about here? What beyond stories? The athlete has done the skill in practice. In competition, no insane person decides to throw in a double twisting, double somersault they've never landed before. Yep. Pressure, fear, heavy dread, blah, 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 academic work. Interviewed 18 elite athletes, students at Stanford, worthy to teach. Writers find their mouth grows dry, their palms slightly damp, and words flow out into the world. All right. How do you get rid of fear, uncertainty, and doubt? Sure. Keep one mind's. Yeah. Okay. It's often thought that the key to quiet the mind's clamor completely. Okay, they talk about like Zen Mode or whatever. But yeah, usually it's not. Usually you end up, in my experience, as someone who's competed at like fencing and everything else, it's not about focusing on the quieting the mind. It's about focusing on one thing and one thing only. Because if you focus on that one thing, then everything else gets quiet, just by nature, right? So if I'm focused on reading, then me worrying about like having whatever I'm doing this evening just goes out the window. So you just focus on one thing at a time. That's really the way I see it. They invite their coach's voice in. Yeah, so I guess focusing on the coach's voice, sure. Cavern, but it's talking about giving another human control of your mind. Yeah, because when you're focusing on when you just need to just go, you don't really have time to think. So you need to basically listen to someone else and let someone else do it. I think this kind of makes sense. Years ago, I toured the idea of studying religion, but in some ways, we are all possessed by others. Yes, that's true. We're all social creatures. A lot of what other people do to us or do around us influences what we do and believe in the future. There's this what's called there's this psychological theory that says that belief, emotion, and action all follow each other. So if you pick like something like belief and action, then belief and emotion go in like one certain area, then action will follow. So for instance, if you believe that whatever you do in practice will translate into competition, and then your emotions follow that competitive nature and that focus, and you're calm about it, then your habit will eventually reach that point. And it's pretty. So you pick like between those three traits, and I do a little bit of this actually in my coaching sessions. If you pick those three traits and you pick two of them, which is really just belief and emotion, then the action will follow it. That's pretty much what you really need. Otherwise, in competition, and once you've solidified the habit, then in competition, all you really need is the belief and then the action, and then the emotion, which is a little bit more volatile. Especially during competition, it will sway, but eventually it will come back to that point where they all meet together. So, yeah, when the professional perform is intense, some even hear the voices out loud. Yeah, they use the coach's voice to replace their own intentions and anxieties. That's correct. I think that's pretty correct, actually. Coming out of ranked 21st in the world, he should have not made the final 8. He missed qualifying time for Rio. What he lies is that athletes have designed their entire lives to get there. Yep, it's clear and brutal, blah, blah, blah. Uncertainty undermines conviction, jolting, it's crowd. Yeah. So basically, it's like, oh god, there's just so much pressure or some shit, yeah. Yeah, they focuses on their coach's words, the timbre, focus on them so intently that the words fill the mental space, yep. If the coach knows what to do, the athlete knows what to do, yeah. So it's basically like, hey, the coach will tell you what to do, and you just do it, right? That's basically what he's talking about here. Well, basically the rest of this, I think this is actually a pretty interesting article. I'm going to link this. But in the meantime, it's 11 a.m., so let's bring my client on and let's see what's up. Hey, hello?
Yo, man.
Hey, what's up?
Doing good. How about you?
Hey, doing good myself. Yeah, so let's catch me up on everything that you've been doing and how has your practice gone?
Yeah, basically, I've been putting to work, like, the main focus you said to me, like, to, like, create an idea of how to solve a question,
Mm-hmm.
you know, and don't get into details, like, in the first moment.
Mm-hmm.
So, actually, every time I'm doing a question, I am asking three main questions, like, the ones that you highlighted.
Mm-hmm.
Acknowledge inefficiency from the naive approach, how it will solve the problem, and like a clear objective where I need to go, without going to the details.
Right. So when I say objective, what I mean is what is the more efficient way of solving the problem. You already presented the naive solution. Now you need to present a slightly more optimal solution.
Yeah, that's what I've been trying to do. Like there was times I was like going to details, and no, that's wrong. I need to be more like the big idea, like the big picture. I even like reviewed our replays, and the moment you said that, like to very solidify this in my mind and the way I approach problems.
Okay, so you watched the replay. Did you notice anything else in the replay, or is it just that?
No, the replay and also our past coaching sessions where you repeated this like over again,
Okay, that's good.
So just to see the level of what is too much detail, what is like just an idea, about how this is going to solve the inefficiency. So that's the main focus I've been putting to work during those past days.
Got it. Okay. Wait, give me a sec. It looks like my audio on my side is kind of fucked up. So let me try fixing it. Okay. Alright, guess that'll have to do, I think. Alright, yeah, keep going.
Can you hear me okay?
I can hear you okay, it's just that it's not capturing the desktop audio anymore, I don't know why.
Let me know when.
Yeah, sorry about this.
No problem.
Okay, wait, I see what happened. Alright, I think that should do. Okay, yeah, let's keep going. Okay, so you watched the coaching and whatever. What's the next thing that you did for practice?
I'd say that I tried to put this framework while solving some lead code questions for the Facebook online assessment. Helped. I'd say it helped. But yeah, the other part was I did like on Wednesday on Thursday. I did like lead code questions. I post on my diary. And yesterday I did the Facebook online assessment.
Okay, so you did practice diary, and then you did the Facebook OA yesterday. How did that go?
Yes. Man, was 4 questions for 70 minutes, right?
Yeah.
From my point of view, 2 of them were medium questions, and one was a hard question, one was an easy question. Like I did one easy, one medium, and when I was in the middle of like going to the third one, the time just finished.
Oh.
So was like bad, I'd say.
Really bad, yeah. I knew you weren't ready.
Things were not like the time you expected, So I don't know, maybe because like the interview, the online assessment, as you mentioned, right? It's better if we had like one more month. And
I knew it was way too soon for you to do the online assessment. That's the thing.
I have the questions if you want to check. I don't know.
Sure. Yeah. I'm very curious, like why it took you 70 minutes to do 2 questions.
Yeah, I'd say that in the second one, though was a question of a try.
Did you try kicking the online assessment down the road or try rescheduling it?
I tried the interview only.
Oh, so wait, this online assessment, are they gonna block you or anything?
No, it's not gonna block me for the phone screen.
Oh god, okay. They're just basically gonna send you to phone screen then.
Yeah. I emailed the recruiter, and she just ghosted me. Like, I emailed her twice. I don't know, like, why this happened, and yeah.
Yeah, I still wouldn't. I still would have rescheduled the online assessment if at all possible, but I'm assuming that you couldn't. So I don't know why, but whatever. All right, show me
And
the questions.
I just like to ask you just one more thing. We were like working in a time frame. Of course, like some of your clients have a different rate of like going to the perfect point. And some things that unforeseen, right? Like the online assessment that we cannot control, the interview that we cannot set to further date. The only thing is kind of in control now is Microsoft interview. But what do you have to say about this? I'm putting my best here, and errors happen, and I don't know. Sometimes I don't know.
Yeah, usually I see people hit their stride by the 6th week. We're on week 5. I expect you to just basically hit it by like week 7 or 8. I would say.
Yeah.
So basically, almost like few more sessions, as long as you're focusing on really improving your replay analysis and your practice diary. As long as you're really really hard on yourself on the when looking back at the problems, and I mean like being merciless, not saying yeah or whatever when you do it. I mean really saying, okay, here's like every single little mistake I made, and I will never make them again. Like that's the level of intensity you need to be at. And I was like, I think I've been stressing that for a while now, but I'm not sure if you've actually done it or you understand what that means. Either way, even R got it in like 6 weeks. If you look back at the practice sessions, that's about the time we basically went to study system design and split our time half and half. He still came out okay. Yeah, even let's see, Valid same way, Pavel same way. I expect by week 6 that you would basically be really really good at these. So let's see what happens.
Okay.
Anyway, we're on week 5 anyway, so
yeah.
Anyway,
you want me to? I think you asked me something.
Yeah, show me the Facebook online assessment questions.
Okay, hold up. Just a minute.
Yeah. And by any chance, is there a way that you can get other interviews? Because like it's like I'm not saying that we're gonna fail Microsoft. I'm saying that in case something happens, do we have another like at least one or two?
I have like my friend referred me for 8 positions in Amazon.
Okay.
I guess like he referred like another friend of ours like 1 week ago, and he received the test like the time frame of 1 week. And I guess like in next week probably I'm gonna be receiving some online assessment from Amazon, but it's not sure, so it's just a referral.
Okay.
And yeah.
Okay. Yeah, we need Amazon. I would like to at least have like 3 shots in case Yeah, at least ideally I would like to have 3 bites of the apple. And I know we can probably hit 2 at the minimum. It's just that when it becomes down to the wire for like 1 and 1 only, that's where things get scary. But
sure.
Yeah, because anything can happen, right?
Yeah, that's what I was thinking the same. Yeah.
Okay, so yeah, just try and get those, keep those in mind. But in the meantime, let's do what we can.
Yeah. Yeah, it's processing the files.
Yeah.
So those are all the questions. Oh, the names didn't. It's a little bit. I put names to it, to the pictures.
Oh, okay. Can you just copy paste it to the doc?
Yeah, I can. Just a minute.
Yeah, it's gonna be a lot easier.
Oh no, hold up. Just give me 1 minute. I'm just gonna upload them in Drive. Yeah. I'm just gonna send you the link.
Okay, cool.
Share.
Yeah, I'm very curious why it took you a long time to do this.
Or I'd say that the most part was for the try, to implement a try, and to cover a few details to pass in all the test cases for the first
one. I didn't mean upload it to a drive. I mean literally copy paste the text.
Oh, that was a picture. Like that was a picture. I didn't
Okay.
like. I was not allowed to take prints or to copy.
Okay,
You know.
sure. You know what? Then I'll type up the questions because I'd rather not show the screenshot. Okay, so let me go to your problem sheet then. So which one is the one that you were able to do? Let's start with that.
Basically, majority of the questions of lists. Oh, you're talking about
Yeah,
just a minute.
for the
Oh.
actual online assessment. Which one was one that you did?
I did the task 3 and 4. Like
Task 3 and
no,
4.
actually task 2 and 3. Yeah.
Okay, task 2. Okay, cool. Oh, I see. You put solve there.
Yeah.
So you're given a string. Oh, this is in the header now. Hold up. Given a string message, replace each consonant with the next consonant.
That was easy.
Yeah, that's pretty easy. Message equals signal solution. Okay, so just briefly, just as a spot check. Okay, got it. Yeah. So this one's pretty easy.
Yeah.
Just run me through very briefly through the algorithm then. Just say it.
Basically, I just disconsider the upper and lower cases, right? And just try to solve the smaller problem.
Okay.
So basically, I first think about to do a map, but it will take me a lot of time.
Okay.
Then I just I remember about this kind of ARD thing that you move to the next letter on Python. So you go to the next character, you know.
What do you mean?
Like if I am in the C, right, the next character will be the D.
Yep.
So I just do a +1 and then I'll move to the next character.
Okay.
So basically, the first thing, like without considering vowels, let me just solve this. And yeah, and then I create a map, a set actually, for all the vowels, right? And while you're traversing this string, if the character is not a vowel, so I will take the next letter.
Okay.
But I think about like the cases of the next letter will be a vowel as well. And then I put a if there. And then I look to the second example. They were like considering characters that are not alphanumerical. And I just had to consider like alpha. Is alpha, that's a thing in Python. I have all of those things here
I see.
on my side. And that was it. Yeah.
Okay. And how long did it take for you to do the problem?
I'd say like 22 minutes because of those edge cases that I didn't cover.
Oh no, they're very bad. Okay, so you missed edge cases.
Yeah, no, but in the end was perfect. Like
Yeah, that's not what I'm concerned about. This problem should have taken you like 10, 15 minutes, but you got there by 22 minutes. That's very bad. What happened?
I'd say that I try to reproduce what I've been practicing of like plan.
Yeah.
I'd say that I got how to say stuck on like my first hypothesis that was not working, like to create this map that I told you. And yeah, later I realized it's been taking me too much time, so I moved to other possibilities. So maybe I could like plan it better.
I think
Yeah, I realized this.
Okay, so wait, did I mention that in the past?
Hang up. Yeah, on my first ideas. Yeah, that was wrong.
Okay, yeah, so you got hung up on your first idea. To me, like this is just a very easy what's it called?
I underestimate this question actually.
Yeah,
I'd say.
it's the way I would have just done this is just convert all this, like iterate through every single string or character in the string, do the integer increment, and keep incrementing if the next letter is a vowel. That does create a very tricky case for that Z. Yeah, it does create a tricky case for Z, though. So you would have to modulus it. Yeah, Z is replaced with B, so it's circular. So you have the modulus.
Yeah, no, yeah. I considered this case. This was the first case I considered. Yeah. because Z is like the last letter. We have to go to the B.
Okay. Do you remember what I said before about thinking like knowing what the premises and the outputs of the algorithm are?
Yes, I remember.
Yeah. So you got hung up on the case with maps. Why did you think a map was appropriate here?
Because I was like, the first idea was like, create a map, because I was not remembering like this thing of ORD, to go to the next character. So I'd say that was the very big waste of time.
Okay, you wasted a lot of time on the wrong idea, but I'm trying to figure out why you wanted to throw a map at it. I still don't quite understand.
To know which will be the next element, So like, I was pretty inefficient because I was trying to map letter to index and index to letter,
Oh, I see. You basically you missed the obvious. Hey, you can just translate a character to.
Exactly.
Okay.
Exactly. That was the question. Yeah, that was it basically.
I mean, even then, it would only take you, what's it called? It should only take you like 3 minutes to, like, I guess write that or populate a map, but because then you would just start A, B, C, D, E. You could just iterate through A to Z, but nah, whatever. Since you didn't know that, that's basically what killed you. All right, fine. Now you know
that is the knife that killed me, literally.
Okay. Next problem. Basically, I get that this might have killed you and cost you like about 5 minutes if you didn't know this one. I would say like 5 to 7 minutes. But if you knew it, then it would put you at 15 minutes to solve the problem. I think that's fine. It's average case, so okay. Next one. Given an array of strings or let's see. Array of strings. Task is to find the number of pairs in which one string is a prefix of the other. So let's take an example. I don't understand this. Like, even if I read the problem, I still don't understand. So for strings equals to backdoor, gammon, backgammon, and door. Solution is 3. Forget the quotes. I don't care. You get the idea with the comments.
Yeah, for sure.
Relevant pairs are, let's see, back and backdoor, back and backgammon, and come back. All right. So you're identifying which strings are substrings of other strings. All right, cool. How long did this one take you?
I'd say that 30 minutes.
Ooh, that's long.
It's long.
Okay. What happened? What was you stepped through everything? What happened here?
I took a note for this. Well, actually, the first idea that I have, like the most naive approach, was to basically compare all the substrings of all the strings given, and see when they form a pair.
Sure.
So basically, that was it. But when I realized that they put on the prompt, it should not take more than 4 seconds to run this.
Yep.
And in terms of time complexity, it will be the worst solution.
Yep.
So from this, I tried to derive my optimal solution. That part, I think I got a little bit trying to see where I can optimize this. It took me a little bit of time. But before our coaching sessions, I remember I did a mock interview where I had to implement a try, and I came with this idea of use a try, so we can search for the matches words in a try, which will decrease our time complexity. And basically, I think the 2 main bad points of this was like I took too much time to implement a try because I was not remembering the structure. It was not second nature to me. And I realized this. I should have to realize this sooner. I will send you here.
Yeah. So if you never implemented a try before, then this probably wasn't a problem that you should have ran with. But I don't think the try I don't think the try is incorrect actually. Um,
Uh,
yeah, if
Look at
you
this.
it huh?
I send you.
Does Python come with a try data structure or not?
I don't think so. I need to know this.
Okay, yeah. Then if you're basically doing something in competition that you've never practiced before, which is very risky. You basically went for the high risk play instead of trying to do another problem. Yeah. It's like let's say I think the try is correct. I just don't know how long it would take to implement it.
A lot.
Yeah, it took a lot to implement it, so that would be like, okay, screw that. Then I would try still going for something simpler. So if I can't try every single possible scenario, what I would do is I would sort the array, and then for first element, I would try the next element. You know, try every single I'll try every single possible combination until like if it's at the front. First four letters until the first letter changes. So I would parse it down. So I would limit the number of um yeah. I think that's the way to do it. So let's say I start with back, you know, then I would see backdoor, backgammon, and then next I see comeback, right? Well, the first letters is it no longer matches, right? So I
Yes.
know that the next two or three letters must be the ones that I just keep iterating on if they exist until they don't. You know, comeback is at the end, so it doesn't exist at the front. Well, actually, it's not prefix, right? So when you do like string.get locate get index at, it should be 0. That's how you tell the prefix. And so here I do that, right? And then I see comeback coming, right? Then I compare comeback to come. But comeback's not a prefix of come, but come is a prefix of comeback. So actually, come would come before comeback. So I'd be comparing back and come. So then I would say, oh yeah, no, this is not a thing. So then I start at come, right, and then come back and then whatever. So basically, it's like this would give me a little order n time actually. Yeah. That's the way to do it, I think. So you n log n and then plus an n level iteration because backdoor will never be a prefix of backgammon.
Yeah.
Well,
for sure.
It might actually because you know backdoor gammon. Then actually, you know, that would fail. So back would be a prefix of backdoor and then backgammon, and then backdoor gammon, you know, that would actually, that might actually be, but that would prune the that would prune it. Yeah. So you just keep iterating. You sort and then iterate until and then stop when there is no when you don't find it as a prefix anymore. So it's about pruning it. I would basically take your algorithm and then prune. I think that's the thing here.
But you would not use a try, right? You wouldn't use a try.
It just takes too long to implement unless Python gave me a try. Implementing your own data structures is very high risk. So you basically try implementing something. I get it. I understand why you did that, but I also think that you could have been way smarter. Like you could have said, you could have realized, wait a minute, it's gonna take you a long time to do this. So basically, you just, I don't know, you just went with, you decide to not do what you've practiced. That's
You know, when you were solving this question, you said prune, like prune the possibility.
Yeah.
When I heard the word prune, like I thought about the same. I need to prune my possibilities.
Yeah.
When I think about prune the possibilities and searching words, the first thing that comes in mind was like a try, you know. So
yeah,
I went in the wrong direction.
You basically could have said, okay, at least let me try it with let me just try it with something I know that works. Because it's like, instead of me constructing a data structure for this, why don't I just do it on something I already got working? It's taking me like a few more lines of code, and it's relatively low risk because you already understand the idea. It's only 1 minute to write. So like when you're doing these things, you want to look for low risk, extremely low risk, by the way. Risk, high reward. You basically are looking for these asymmetric opportunities when you're progressing through these problems. And what you did was you took the high risk, high reward. You could have just because if I just, modified the naive solution, it's only taking me a minute, which is the risk is that 1 minute. but the reward is I could possibly solve it. So that was your mistake there. So you basically just did. Go ahead.
I have one question. I was even talking to a friend, like, even though I could save like, let's say 7 minutes from the first question, and I'd say like 10 minutes or 8 minutes from the second question. Do you think, I don't know, like, one more question I was able to solve, right?
Yeah, I would have liked for you to solve at least 3 out of 4 on these.
It would be much better.
Yes. And so basically you got killed because your inefficiencies. Also, keep in mind, you said you missed your edge cases. So if you spam the compiler and it keeps saying, oh, you're wrong, and you do that over and over again, that does deduct your score, by the way.
No, I didn't spam the compiler. I just like, I run the first time and, oh yeah, I consider like, I cover all my edge cases.
Okay, but then on the first problem, you said you missed the edge cases.
I missed like in the first attempt.
Okay, just the first attempt.
Yeah, but when I submit was like all the test cases.
Okay, cool, perfect. Okay, that's fine. Yeah, so basically 7 minutes there. I would say even upwards of 10 to 15, depends on how long it takes you to implement a try.
Okay.
Well, I'm going to guess that implementing a try, testing it, make it you've never done it before, I would say it's about 10 minutes. So I think about 10 minutes would have saved you. So that means that would have given you, what, another 18 minutes plus the additional 18 minutes that we have here, 36 minutes. Yeah, that's better enough. That's enough time to do a third problem, and then you could even do one more. Yeah. Yeah. So if that's the case, did you get a chance to try the other? What's the next problem that you went to?
I went to. Let me just see here. Yeah, it was when I was about to start the first one. Like 3 minutes, wrap your thing up, and I wrap this thing up, and it's gonna end.
Wow. Okay, so you took longer than the 22 and 30 minutes that you gave me. You said you took.
No, but I revisit like all that I did just to see if it was like the best thing, because I think to myself, I don't know if it's that right. I need to guarantee that was the best thing I can do instead of try one more problem like fully, you know. Yes, that was it. I was kind of nervous as well.
Fine. I mean, like with 3 minutes left, and you said, oh wait, you said you had 70 minutes or 60 minutes?
70 minutes.
Okay, so there's an additional 18 minutes that we're missing here that was not accounted for.
I'd say, okay, sorry man, I didn't track my time for those questions.
Okay, that's fine. I mean, I get it.
But I'd say that I probably spend more time in the second question, like in this implement the try. Yeah, and probably, yeah.
Yeah, so basically you got killed on doing basically something that we didn't do in practice.
Yeah, for sure. I'd say, yeah, the biggest thing I can get from this was like this try thing, you know. Was a workable solution, but was like the worst thing I did.
Yeah, it's like you're doing something that we never talked about in practice, so it's like I can't help you there. Like if you decide to throw the practice out the window, then it's just like you know, I can't do anything about that.
I act like a suicidal. Yeah.
Yeah, it's a suicide.
Yeah.
All right. Anyway, so now you know, don't do something that you haven't practiced. Like, and let's hopefully you don't run into any other mistakes, but I'm sure you're gonna run into a few other ones. I guess let's actually do this. I want to see how you would have performed for like the hard question here. Which one do you think is the hard one?
Oh, that one. Let me show you.
The task 1 or task 4?
I think it's the 4. Yeah, that is the 4. Yeah, I consider as the first one.
Okay, let's see. Beauty of a 2 by 2 square matrix is lowest positive integer which doesn't appear in the matrix. So the matrix consists of 1, 2, 4, 6, then 3. The lowest positive integer. Okay, yeah, got it. 2 by n matrix positive int for which n is an even number. Arrange the matrix elements such that matrix into non-overlapping 2x2 sub matrices. Arrange the sub matrices in ascending order based on the beauty of each one, and combine matrices into a new 2n matrix. Holy fuck. The order should be arranged left to right. Order, in the case of a tie, place them in the relative order they were otherwise original order. Jesus Christ. So much fucking reading. Like, I am not smart. I hate reading like this, you know? So, I don't know how other people do it.
No, for the same reason I just said this as the hardest one, because, man, it's too much rules, you know?
Too many rules. Like, I don't want to read. I'm not here to read. I'm here to solve fucking problems.
For sure.
Fuck this.
For sure.
Okay, let for the sake of it, now that I understand somewhat what they're asking. 10, 1, 2. And then you also have, 3, 4, 10, 2, 5, 4, 4, 1. And then the solution would just be to have you want to order the left to right in the case of a tie, preserve the order, but then the internal, what does the internal order matter? The order elements within, yeah, it should be preserved, but then in the example they give, it's not preserved. The fuck is this?
Yeah, there was even an animation, like a GIF, you know,
Okay.
like explaining. I didn't take a picture of that.
I don't care. Doesn't appear in the matrix. Okay, so you have a beauty. So then split the matrix into two overlapping. Okay, you need to split the matrix into overlapping. All right. Overlapping. Okay. Order the submatrix left to right. It's not hard in the sense of it's difficult. It's hard in the sense of I don't fucking understand how they even get to the solution.
Yeah, for that reason,
what the
I just
fuck?
yeah, that's the last one I will try.
Yeah, fuck this problem. I hate it. All right, let's try the easy one then. You say easy as in like easy to do?
I mean, I would consider it as a median, but was not like this absurd, you know.
Yeah, that problem is fucking absurd. Fuck that. Alright, so you want to... Okay, let's try the other one. Arrange
Test one.
elements in
Test
pairs. First element with the last one. Second element with second to the last. Okay, got it. So you're basically swapping the first end in back. Okay, got it. First element. The element should be a sort. Okay, so then the elements sorted in ascending order such that positions should be swapped if the left element is greater than the right one. Okay, so you're just comparing the first element and then the last element. Next element and the next element. Says the position swapped if the left element is greater than the right one. If proceeds possible, can combine them into an array for the output. Okay. Got it. Cool. I like simple examples. 5, 7, 3, 2, 1. And then the output should be 1, 1, 2, 5, 5, 3, 7. And then the example, you have three possible pairs. 1, 1, 5, 2. And then 7, 3. And then you rearrange, and then you combine them into a sorted order. Because each one is sorted. Got it. I'm actually, you know what? How about this? Why don't you do the problem for me? Why don't you code this up?
Okay.
I'm very curious because this one actually I feel like should take you like 10 minutes. Like it's probably or like no 15 minutes because 5 minutes to understand it, 10 minutes to write it.
Okay. Okay. Just a minute.
Okay, I'm gonna get a timer out because I already know. Like, let's just basically write the fucking code for it. This is not very difficult.
Oh yeah. Just let me open here the prompt. Hold up. Just close the drive.
I mean, I kind of reproduced it for you here, so.
Yeah. Oh, okay. Go ahead. Yeah. I just opened here the page. Okay. Array of integer array. Arrange the elements in pairs with the last one, and second element with the second last one. Okay. Element sorting in ascending order. S. The positions should be swapped. Left element is greater than the right one. Okay, so taking this first example here, let me just see one thing. 1, 5, 2, 5, 3, 7. Arrange the elements in pairs. Okay, I need to compare them in pairs. First with the last one. Okay, so this should be compared with the last one here. Yeah. And the second, actually, the first should be compared with the last one, and the second should be compared with the second last one. So, yeah. Okay, so we go from, just walk through this. Okay, so in this case, I have here, I will compare the first with the last one. It will be the same thing. And can you hear me?
Yep, I can hear you. Go ahead.
Okay. And then I will compare the second element. Oh yeah, the second element with the last one. The second last one. In this case will be 5 compared with 2. So I need to, it said to me that it needs to be ascending order. So it means I have to take the one that is the minimum. So in this case, it will be the 2. All right. And then I will go to like 5 here and do the same thing. So another 2 pairs. I'll compare this first one with the last one. The left one is greater than the right one. Should be. Okay, there was another thing. I just have to swap the elements, so this 2 is going to be here, and this 5 is going to be here. Yeah. I just need to swap. I thought another thing. Anyways.
Okay. But then how about 1 and 1?
I'm not going to swap because I'm just going to compare, and they are equal. There are no swaps here. Yeah, and then one thing here, I just need to, because I have to see if there is a way I can, yeah, it's gonna be out of order. So I need to, actually, I need to keep track of the elements I visited, but one thing, elements inserted. 5 with 2. Five with 2 and 7 with 3. Okay. Basically, let me try just one thing here. I'm just going to move to the next one just to see if I repeat this until it's.
Okay, I'm gonna treat this as if you're doing an online assessment. I'm just gonna watch you. So.
Okay. Okay. Imagine that you're not here.
Yeah,
I'm
I'm
not
not here.
online assessment. Positions should be swapped if left element is greater than the right one. If left element. I'm just aware of, okay, comparing 1 with 1 and then 5 with 2. That's clear. And now 7 with 3. And, but, okay, 2 and 5 because like, okay, got it. So yeah, 1 with 5, and then I would compare, like, I'm gonna be in the second one, in the let me just look here. Give me 3 possible pairs. All right, after arranging elements, each pair is ascending order. All right. Oh, okay. 1 with 5, 5 with 2, and 7 with 3. Oh, okay. I just looked to the example on Drive. And then after rearranging the elements of each pair ascending order. Yeah, so the answer, okay, now. Hold it. Okay. I just compare 1 with 1, no swaps, and then I'll compare 5 with 2. And then there's a swap here, 2 and 5. And then I'll compare 7 with 3. Seven with 3. Look into the example that they gave me. Mm. 1, 2, 5, 3, 7. Just compare 1 with 1, and then 5 with 2 here, and 7 with 3. Okay, and after, like, I do the swaps. And 5, okay, 3 and 7. Nice, 2 and 5. Yeah, what I did wrong here? Just a minute. 1 with 1, okay.
I mean, I would say you look at the example. I mean, it tells you very clearly, right?
No, yeah. I just it's because I shift content. I went to the image, but it's the same thing. Just to see if there's anything else. Okay, yeah, 1 with 1, and then. Oh yeah. No. How can I don't see this? It's just like I have to start iterating, maybe from the beginning and from the end, and then compare the elements and then shift then when they like are greater, like the first is greater than the last. But just let me make sure of one thing here. Yeah, first I can create the pairs. Like, let me just think about the most naive approach here. Why this? Create the pairs of changes and of like comparisons, actually comparisons, and and like while create a pair of comparisons. Okay, so I'm just gonna write the general idea here.
Go ahead. Yep.
So the general idea is to iterate the array from the start and the end, comparing the values and shift then if needed. So that was the general idea, and then going into more detail is I'm just gonna implement the code because it's too simple here. I don't know why I was creating difficulties. So range array, which are going to receive this array, this original array here, and yes, basically I will have a start in 0 and then end in 0. Then like while and while end is greater than start, will I have to increment the start by 1 and decrement the end by 1. But before this is where I have to do something. That is, if if the start value of the array is greater than array end, I should shift them. So basically array start array end and array start. I'd say that was it, and in the end I just have to return the array. Let me just do a test to see if that makes sense. Otherwise I just have to decrement, and that's pretty much it. So taking this first example here, I will start with this array called start here, another array called end by the end. No, actually, that is the length of the array, -1. So that's it. And then I'll compare 1 with 1. The array starts, it's not greater than the array end. So I'm just going to move to the next iteration. So I increment starting in decrement end, and I'll compare 5 with 2. In this case, the start is greater than the end, the element represented, right? So 2 here, and then 5 here.
Okay.
Yeah. 5 with 2. All right. And then 7 with 3. And 3 and 7. Yeah, and then I'll stop. But it's not the output that we want.
Okay.
And then I have to do this comparison again. So I need to find a way to do this comparison again. Just to start over, because I realized that's not enough. So So yeah. Mm. 2 and 5 and yeah. Also, I need to. Oh yeah, I didn't plan as well. Like I need to move the pair to the end. Hold up. Okay, step 1 is done. Let me. Okay. After doing this, I'm gonna have this result here. Compare. I'll compare this with this. I'm just looking for a way to. My goal is I need to have them sorted, like the pairs sorted. So I'm just checking how can I do this. Because the comparison, it's very straightforward, but like, okay, I'll compare 1 with 1, nothing will happen. But this one, yeah, this comparison.
I'm gonna stop you in 3 minutes. Because you're at 17 minutes already. So.
Okay, this comparison should be here. And then we need to go to the second comparison, that is 5 and 2. And then, yeah, I will just swap them and then take their values and, yeah, just let me allocate another array. Then put them right here. So this will be 2 and 5. 2 and 5 here. And then the next comparison is 7 and 3. So I'm gonna shift them the same way I did. 3 and 7, but then I'm gonna take their values and put here, like 3 and 7. Yeah, and then there's the output. But there's the inefficiency of like allocating another array. So let me just at least make. So I would have like a result here. And for each one of this, I will, yeah, just append on the result. Like, yeah, the array start and the array end. So this followed by this. And in the end, I'll just return this result. Yeah, the inefficiency, as I mentioned, I'll have to allocate another array, that is this res. And of course, probably there's a way I can do this in place.
Okay, stop. Let's stop there because you basically solved the problem. Keep in mind, the only constraint you have is time, not memory. At least according to the problem, right?
No, but I have to allocate another array.
Does the problem say that you have to, or that you're constrained on memory as well?
I'm not sure.
Roger, look at it.
Hold up. It says that, okay, input and output, execution time limit, 4 seconds. Input array. Array integer. Yeah, there are no constraints, actually.
Okay, so there's a lot to talk about.
Only in time, yeah.
There's a lot to talk about. You spent 20 minutes on a problem that should have only taken you 10 minutes. Do you know why?
Lack of planning.
More specifically...
Lack of planning, I mean... first, before the code, come with an idea that will work. Like, really make sure that my idea will work. And I test this, showing the output without going to the code straight.
Yeah, pretty much you basically tried going for an idea that didn't work. Like, what I saw was you basically getting hung up on this idea of swapping. When clearly it doesn't work. Like, why would you, like, you're swapping the elements, but you didn't even understand the examples of why the examples were the way they were. You just kept getting on this idea of swapping, and I was like, why? It took you 10 minutes to realize, hey, wait a minute, maybe I should understand the example first before I come up with my own ideas.
Mm-hmm. Yeah.
So you burned 10 minutes literally just trying random stuff that didn't work. And you're still hung up on that. Like, at the beginning, you're like trying to swap the elements. Oh, that's not giving me the answer. Oh, and you're like, oh, what if I tried this? What if I tried that? And then 10 minutes later, like, oh, let me actually look at the examples. Like, oh, okay, I see what the example's doing. But then you're still kind of doing it here, you know? You came up with the code, and you went right back to the idea that didn't work. Why? Just implement the example. That's it. And it's like, if you just went with this first, what you did here, you could have just done that. Just do this, submit it, and then if it says, oh yeah, you took too long or you used too much memory, it's like, okay, we'll address it. But at least we have a solution. It goes back to the idea of just coming with a naive solution first, and you're trying to over-optimize it. So the problem I see here is that it's the exact same thing that you mentioned in the first problem. You came with some nonsensical idea that didn't work, and you're still chasing it.
Mm-hmm.
So to me, you didn't learn from your mistakes at all. You're making the exact same mistake. Remember the first step, come up with a naive solution.
To be honest, I was not understanding the example. And then I just realized this later. Yeah.
Like, okay, so what part of the example did you not understand? Because it literally gave you the explanation.
I was actually, I was okay, understanding that is a comparison, like 1 with 1 and then 5 with 2.
Okay.
But I was not like connecting the idea that, okay, also this needs to be in the right order, you know? I was just hung up on the idea of like, I need to swap in case they are greater than the other.
You're swapping inside the array. That's the difference.
What you said?
The way I saw it, like, you were swapping elements inside the array. You were trying to swap 1 and 1, 5 and 2, 7 and 3.
Yeah.
That's what I'm talking about. I'm saying that's wrong because you should just look at what they're giving you, and you went to this shit instead of try to do it in place. And what I'm saying is, you doing this in place is wrong to begin with.
Yeah. I got the idea.
Yeah, the idea is you just basically try to over-optimize, create some random-ass solution, and then you look to the example, and you say, hey, wait a minute, this example doesn't make sense because I came up with some random solution that I think works. But literally in the example, they're telling you the step-by-step that does work. So maybe just code that up?
And optimize.
Then optimize, yeah, it's the exact same thing we've been talking about. Come with a naive solution, then do the optimal one. In this case, they're literally handing you the naive solution on a platter in the explanation. So I don't know why you come up with this random shit, but it's the exact same thing that you mentioned in the beginning. Like, it's the exact same problem. You're inventing random solutions again. So that's what I mean by you haven't learned from your mistakes.
Yeah.
Right. Yeah.
Okay.
Right. Show me your practice diary. Let's talk about that.
Mm-hmm.
Yeah, you could have done a whole lot better if you just didn't make like those mistakes, actually.
Man, one thing I think I have to say, I don't know if it's like it's the same thing, but yeah. Like one pattern. I'm not just complaining about anything. I'm just trying to solve the problem, right? One thing. I don't know why this happened. When I am comfortable with the problem, I mean, like when I kind of think ahead and okay, I know what can I do to solve this problem. I can come up with this idea of okay, make this work, then you can go to this optimized one. You know, then that's pretty clear as water to me, right? I can follow exactly what you said to me. But sometimes when I have didn't realize the problem yet, I perceive that I don't know. I kind of yeah, I'm not comfortable. I need to solve this problem. Okay, and then I try to break down, but sometimes I don't know. I go in the wrong direction. I try to address the inefficiencies that was happening. I try to make the example like as the same as the example, and yeah, I feel like sometimes I get eager to solve the problem, but instead I should be methodical. Yeah, it's like the same things we talk like the past weeks.
Yeah, pretty much. It's basically you're trying to invent the solution. Like, oh, let me reinvent it from scratch. Let me be brilliant. It's like, but there's an example that is telling you how to solve the problem. Why don't you try understanding the example first?
Yeah.
It's like, let me go reinvent the. You're basically just talking about reinventing the wheel.
Basically that.
Yeah. It's like, why don't I just try understanding how this wheel works on a car instead of me trying to invent a new wheel? That's all it is. And you're trying to be clever and trying to be smart and whatever. And really, these problems are just take the free lunch.
Yeah.
Just it's a free lunch. You don't have to make things do it for your own. Just literally, hey, they're handed to you on a silver platter. Just take it.
Let me try to do the same thing as them. Maybe that's the mindset. Yeah.
The mindset should be like, hey, let me understand what exists in the world. The mindset should be, let me get the free shit first before I try making things complicated. That's what I saw. Again, that's this idea of just extremely low risk, high reward. Like in this case, it's like that's what caused you to do the try thing. So, but before you do something that's extremely, this is gonna take me a lot of effort, it's a lot of time and whatever. Let me just try all the free lunches. Let me try all the low risk stuff, the easy stuff. That's perfectly rational. And what you do is you try being clever. I'd rather you be like rational and logical than try to be clever and brilliant. That's all this is. This is basically how logical you are. So if you want to be brilliant, then you just go be like a PhD physicist. Like those people are fucking brilliant. I can't do that shit.
Yeah. No, I can't do the same. Yeah.
Right now, we're talking about executing on ideas, and the simpler the execution is, the better it's gonna be. And all you're doing is trying to be brilliant with it.
Yeah, I feel like it's something. The whole mechanic I've been constructing the past weeks, I just abandoned, right?
Yeah. Don't be brilliant. Be brilliant.
Yeah.
Be logical. Be simple. That's all you have to do. Just keep this mantra in mind. It's like, am I taking the free lunches? It's like, like it's those free Costco samples, or like, like you go to a talk by someone who is giving out free food. Why bother spend 50? Why should you go spend $50 at the cafeteria when you get like a free chicken sandwich by just going to this freaking talk by some fraternity or whatever?
Yeah.
Like, just get the free fucking lunches. It's free. It's in your face. Just take it.
Actually, a few of the exercises from the diary I just made on paper just to be with this idea very clear.
Sure.
I will just send you.
Okay, let's see. Let's see what you did in the practice diary.
Basically, you said to me, like, do stacks, right?
Uh-huh.
Until you feel comfortable. I don't know if it was because of the online assessment.
It was the online assessment. I was thinking that maybe they would come at you with a stack or something.
Yeah, and focus on linked list, right?
Yeah,
and that's what I've been doing. If you see, there's a bunch of list exercises.
Cool. All right, okay, let's see. Consider the case that employee could have a 1 hour free. Okay, so this one is array and interval. Great. This one is grokking or EPI?
Yeah, that's grokking. I guess it's the problem challenge. Let me just confirm here. Problem challenge 3. I can send you what I did. Hold up. Hello, can you hear me?
Yeah, I can hear you. So you tried doing it's a challenge problem from grokking?
Yeah,
Okay, cool. Let's open up grokking.
just a minute. Because some of them I do on paper and some of them I do on Visual Studio, then copy to the doc. Employee free time. Yeah, that's it. If you want me, I can send you. Right?
I'm logging in. Hold up. Nah, they keep kicking me out after like fucking whatever. I mean, yeah, actually, why don't you do that? Yeah, send it to me.
It's with the prompt, so it should be easier for you to.
Okay, wait, hold up. They're asking for 2FA. Fuck. I wish they would stop kicking me out of my account.
Oh, actually, that one is one I will redo, because I didn't consider an edge case.
Okay. Yeah, so the question, I'm trying to figure out why you missed the edge case again. In general, we want to like avoid those because those are like those are controllable mistakes, unforced errors.
Mm-hmm. Oh, that's it. It's too long. Your message is too long. Oh,
No, it's fine.
Upload as a file.
Just put it in the problem sheet or something.
Yeah. Oh, just those who have a nitro, right?
Yeah. Just put it in the sheet.
Okay, I think you can see. I don't know.
Okay. I was gonna say.
I sent as a file.
All right.
Oh no, still. Yeah, you
All
can
right,
see
it.
the entire.
Got it.
Entire thing I did.
Yeah, that's why I said put it in the sheet because that way I don't have to like copy paste it, but whatever.
Oh, okay, sorry. There's a.
There we go. Okay, for employees, like what the heck? It's weird. For K employees, okay. For K employees, we are given a list of intervals representing the work hours of each employee. Our goal is to find out if there is a free interval that is common to all employees. You can assume that each list of employee working hours is sorted on the start time. Okay, so employee works hours. Okay. Okay.
Do you want me to say like the edge case that I missed?
Yeah. So go ahead.
I just consider like free time. That was maybe I just took on my note. That was the thing I would ask for the interviewer. I just consider free time like between the time you start to work and finish to work. You know. Okay. And I was not considering free time after this because I think to myself, well, maybe all employers should be like maybe in their lunch time, you know. And then I didn't consider like other times, and Grokking was considering this, and basically that was the only thing that I did consider. And for some employees, they only have one time slot, you know, so they work from 9 to midday. That was it. Basically, that was it. I was trying to consider that all, like the free time between the working hours, you know, into their working hours, not like after they stopped work. Basically, that was the thing.
Okay, so you didn't consider the full workday. That's basically it. But it even says here, therefore, should have considered the last example where there was an unhappy case of one slot of time per employee. So it's the same example, it's the same problem. I think it's that you didn't consider the examples. You didn't try understanding them. It's like it's a free lunch. Hey, they're saying, hey, this might be a unhappy case you want to think about. Do you have any other ideas from this? At least that's what I'm seeing here. So this just goes back. Just look at the fucking examples. They're giving it to you. Like try to understand like that, and then just like also the edge cases as well. But yeah, basically, what I'm seeing is that you're eager to solve the problem. You're not eager to make sure your problem is correct.
Yeah. So that's a point.
Yeah. Remember what I said. Where are you gonna go die? If you can't answer that question, you should not write code. That's the thing.
Yeah, if I consider all the examples, I will realize that in the last one There was only one time slot.
Yeah. Let me write that down on your sheet.
But one question: can you just just give me please a feedback in terms of how I evaluated in this problem in terms of like defining where I need to go. I don't know, like if it's the way you want me to.
In
go.
the online assessment?
No, I mean in this problem I showed you.
Oh, okay. You want me to actually look at your work? Okay, hold up. Give me a sec.
Yeah,
Let me
because
finish
that
this.
one. Yeah.
Do not write code until. Okay. Let me see. Let me look at it.
Mm-hmm.
Okay, there's a free interval that is common to all employees. Yeah, let me make sure I fully understand the problem first. Both employees are free between 3 and 5. Okay, yeah. So the overlapping free work hours, sure. So they're employed. Okay, so the second one, 4 and 6. So there's an open interval between 3 and 9 for the first one. 4 and 6, 4 and 6 overlap. Okay, so you have 1 and 3, 2 and 4, 3 and 5, 4 and 9, and then 5 and 7. Okay, so employees are free between 5 and 7. Yeah, so the work hour would be defined by the minimum number you find here, maximum number you find here, and then you would, yeah, and then that's those limits that you would look at. Okay, now I understand the problem now. Like I literally just go through the example and just say why they get the answer that they did. Okay, it's like what else do they think about? Okay. So let's see what you did here. 1 3 5 6 2 3 6 8 1 3 5 6 2 3 6 8. So the output is 3 5, right? So you did an overlap 1 and 3, 5 and 6. That's you 2 and 3 5 and 8. Okay, so you kind of just drew it out. Naive approach. Fill an array, or I don't know if you fill an
the
array.
same idea.
Oh, you just drew it out, so you fill an array, right?
Yeah.
So this should have told you.
That's.
Yeah, so this should have told you already, like your working hours or whatever. They should have prevented you from running into that mistake that you saw. So whatever. Okay, fine, that's fine. Objective: instead of allocating an array in which all interval slots are used, compared to the times in which the employees have free time, discover each. What? Instead of allocating an array, consider all the interval slots that are used to. Okay, compare the times in which all the employees' free time, discover each employee free time, and check their overlapping case, tracking the start and end time of the what?
Yeah. Of the employees.
Okay, so I would say that this is still like your explanation is still kind of crap. I don't understand. Like it's like compare the time in which all the employees' free time. You just need to, so you're basically saying just compare all the employees' free time. That's basically what you're saying, and then just see those and just see where those overlap. That's a simple explanation. So, what I'm noticing here is that the ELI 5 here needs work.
But one question: is this not the what the problem said? Again, like compare the free times overlaps.
Yeah, this is and right now, your naive approach is really to like look at the zeros out. This is fine. Instead, you are repeating yourself here, but it depends on the context you're using. You are kind of repeating yourself, yes. But it's how will it solve the problem? Because knowing all the employees' free time, yeah, it's tautological. At this point now, it's tautological. You discover an interval they have in common. The reason why I say it depends is because most people would only look at the working hours themselves as the working hour intervals, and what you're saying is to invert it instead to create intervals of the free times.
Yeah, that's the idea.
That's not bad. And if you say things in that context, then that makes more sense. Because the difference between what this explanation is on its own versus what I just did, I put in the right context to show me how it's going to solve the problem. I said, hey, instead of looking at the work hours, let's look at the actual free time itself. That's the difference. It's the context in which it resides in. So it's not. I don't think you did what's called a bad idea here. I think that
should be more succinct.
I would say like make it more precise. Like why?
Okay.
Extra space. How to solve the problem. Okay, so then now you realize you still have a little bit of time-space complexity. Yeah. Instead of collecting all the intervals, compare letter. Compare the overlaps of free time while traversing the employee free time. Compare the overlaps of free time computed while traversing the employee free time. Okay, so you're looking at the work hours again. Traverse through all the employee intervals. Consider the free time to start the maximum of the current start and start. Consider the free time end to be the minimum current end and end. So you have this 1, 3, 2, 3. So I would definitely want you to walk through the example if you're here, but you're not. So whatever. So then let's see. So you start with 1, 3, and then 2, 3. And then, so then your maximum current start is 1? The free time start is 3. Okay, and then which interval do you consider next?
Yeah, the interval is going to be like from the first iteration, right? It's going to be 3 and 6. That's the interval. But when I will be iterating to the second employee, this interval is going to shrink to 5. So that's their like overlapped free time, because it's going to be the minimum between the second slot that they start to work and then like the maximum of where they stop to work in the first slot.
It's hard for me to tell if you did that, because to me, like right now, the explanation still kind of sucked, to be honest, and it's not immediately clear. Like the way you should like be writing this is that someone with no context of the problem could be handheld through the problem just by reading your work. Like if you look at like all the other stuff that I do, it's like I write the minimum amount, but I write enough that the person can understand what solution I'm doing, and I'm not getting that from yours. So it's kind of hard for me to really understand what you're doing. So the ELI5 definitely needs work. I get you're trying to do what we talked about here, but to me, it's like, because I can't tell what the objective is, it's hard for me to say. Like, let me ask, like, if you read this, can you understand what's going on?
Without the context, let me just try.
Yeah, just like pretend you have no idea how to solve this problem. Pretend like you're empty slate, and then start reading.
Okay.
See if you can understand it.
Okay. Instead of collect all the intervals, then compare later. Compare the overlaps of free time computed while you're traversing employer's free time. Instead of collect the interval, compare later. Yeah, this first line is nonsense to me. And the second one, compare overlaps of free time computed while you're traversing employee's free time. I think the second one make more sense, but maybe it needs to be refined.
Yeah, it needs to be. Yeah, it's basically like if it barely makes sense to you and you did the problem, then it's not gonna make sense to me, who has not done the problem. So basically, we rewrite this to be more readable. This is not unlike the red tape blue tape problem when it comes down to it. I think.
No.
In this case, it's just like what I would do is for every single work interval, instead of trying to look at the overlaps, I would literally just create a new a set of intervals of free time and then just check the overlaps on those.
My idea was to create one and then comparing this one interval. But anyways,
okay.
I will redo this problem.
Yeah, I want you to redo it, and I want you to when you write these stuff, I want you to really consider if someone who is 5 years old and has never seen the problem before can actually read it. So it's the ELI5 problem all over again. All right. So it's hard for me to judge. Let me see if there's another problem that you can give me that I can see. But really, you should be I think it's a little bit better I get the sense it's a little bit better because of like the consideration you're doing, but I definitely want to see you clean up your explanations.
Okay.
Let's see what your other things come up with. Instead of reversal, the nodes between P and Q, find Q and take the delta. The thing I did not consider here is the delta fact. Though the value will not always be in order, so I stick to it and therefore to make sure to validate this. Instead of the reversal of the nodes between P and Q. Find the P and take the delta. Okay. And take the difference between. What is the difference between a node? You mean the sublist?
Yeah, like the distance of them.
Okay,
That
so you
was
take the
what I
distance
meant.
of them, and then invert
Yeah.
this amount of times like the normal. So you're basically talking about reversing a sublist in a linked list.
Yeah.
Okay, you could clean up
I'm
your
just
explanations as well. Yeah.
I'm just trying to find this problem for you. Hold up.
I know the problem actually.
No, I
But
mean like my solution.
okay, but yeah,
Because I think the
basically your explanations need a lot of work. I'm gonna say.
okay.
So it's ELI5 again.
One question, just to see if it's on the right way. If I manage to make those explanations more clear, the 5 years old kid understand, like defining this objective and acknowledging the inefficiency. Do you
Yep.
think maybe that's basically what we're trying to get out of this, right? At this moment, in this
Right
moment.
now, I'm trying to identify what mistakes you are making right now. It's at this point, I'm trying to figure out like, okay, how can I make it so that way you don't make these past mistakes? I feel like we're kind of repeating the same past mistakes. So I'm trying to figure that out. Because me, it's like it's the very simple like 3 steps, right? Go with the find the simple naive approach. What is wrong with it, and then come up with a more optimal solution as your objective. It's just those 3 steps, and and it seems like from time to time you're coming up with random things that throw it off. So, for instance, like today with the online assessment, come with a naive solution. You literally have an example that will tell you what the naive solution is, and you kind of threw that away in order to try and be brilliant. We've talked about this in the past, and also trying to be a little bit more objective. We've been working on that for the past like 2-3 weeks, and then at least you're able to identify the inefficiencies of it. That one I think comes to you pretty easily. But then it's like being able to link the more optimal solution from the naive solution. That's again, this tendency to try and be brilliant instead of trying to build on what already exists.
Actually, let me just check one thing. I'm not finding this problem, but I did it. I should like every problem that I do, even that's on paper. I'll just take a picture and put on the drive, so I don't.
Yeah, just do that. If you do pencil paper, put it on the drive, and remember, just like, always keep it simple. If not, everything should be as simple as possible and no more simpler.
Actually, can I just show you? Actually, just one more, just to see if maybe it's more connected to what you want me to do.
Yeah.
Here, the code's in the back, and this one. Actually, okay, I'll send you.
Okay.
Okay, there we go.
Okay. Okay, a little bit blurry, but let's see if we can make sense of it.
Let me know if you want me to take another picture.
I can download it. Hold on. open it. Let me rotate it. Okay, cool. Okay, yeah, I see. First idea: traverse the list, keeping track of what node I'm at. Copy in case it's odd. Store node to the end of odd list. Same for even. In the end, take the left node of every list and link with first of odd list. Okay, so let's see. So you're traversing the list, keeping track of what node I'm at. Copy in case it's odds. Store node to the end of an odd list. Same for you. Okay, I understand what you're saying here. Your explanation needs a little bit more work, but it's fine. Counter equals 0. Insert the end of odd list. Insert the end of even list. That's fine. Yeah, and then join the list together. So what's the better solution here? Since I'm creating new lists and allocating. So instead of creating new nodes, I'll try and use the same nodes. So basically, you're talking about I'm using extra space. Why? I just need to do it in place.
Yeah.
That's basically it. Yeah. You could that's the easiest way to say all this. That's actually
just being.
You need to be it's like
less
when
wordy.
I say simple in explanation, I mean really simple. Like you'll notice this when I talk and when I write things, I literally try to use like 10 words or less. Like I even type in fragments, even when you see like go back to the practice problems. I like literally just write out iterate through a list for every, and then next line for every element. You know, I don't try to make my sentences run on. I try to make them so that way that someone even with the attention span of a goldfish can understand. That's kind of like, I think you should probably try maybe think in that direction. Imagine you have like a small retarded fish or some shit, you know, and you're trying to explain it to him. He's like, I can't pay attention for more than 5 seconds. Or like I can't read a sentence that is very very run on. So that's basically it. Part of it is like formatting. Part of it is like like sentences, but it should come down to the same idea. So yeah, I understand what you're doing. You're basically skipping elements and then you're linking them to their skip. That's fine. Yeah, that's basically that's the right idea. So that's fine.
Yeah.
Okay. No need to reorder pointers. Original list. Okay, create a list. Okay. Same solution, but they use a trick of traversing a list to alternate nodes to be much more concise solution. Okay, this looks like. Yeah, EPI solution. Just move forward until elements are not repeated anymore. Stuck. Have to remove the stock solution. Check EPI solution. It's just to invert the second half. Compare. Okay. I'm curious about this one actually. It's singly listed palindromic.
Hold up.
And I want you. I also want you to highlight which ones you were able to solve and which ones you weren't.
Okay.
It's kind of hard to tell. Yeah.
Actually, the difference of API solution is that they are alternating between pair and actually even and odd, you know, that I didn't think of. Just a minute, I'm just gonna. Ooh. Yeah. Yeah, this one I did on paper. Just a minute. The idea for it is on the pictures, but the code The actual code is on the text. Yeah.
Okay. Okay, so you have the code for it. Great.
Yep.
So let's see what you did here. Okay, 87 and 88.
That is the problem, right? Oh, actually, oh, sorry, that is the palindromic.
Okay.
You want me the even and odd merge. Sorry about that.
Okay. I'm about to take a look at this since you sent it. Wait, where's your practice star? Where did I put it? Cool. So this is this is even odds, right? Or
Yeah.
okay. Even odd merge. Okay, yeah, I'm curious what you did here. Okay, wait, yeah, this is the same one. Yeah, I think this is pretty much the same one. Yeah, this is the same one.
Which I'm just.
Yeah, don't worry about it. I'm waiting.
Oh yeah, you found. Oh yeah, that is the. Sorry, I just sent you the explanation. Oh, sorry, man. It's a little bit messy. I'm gonna.
Whatever. Yeah, I'm waiting.
Organize this because yeah. Yeah, actually.
Okay. Let's see, API solution, just move. Okay, for what one number 139, what was the difference? You wrote the API solution, but you didn't say what you did.
On 139, right?
Line 139, yes, I highlighted it.
Is the one I sent you in the picture.
Oh, it's the one you sent me in the picture? I thought you sent me even odd merge for some reason.
No, 139. 139, even an odd. Oh, actually, remove duplicates in a linked list. Okay.
Yes, line 139.
Yeah. Now we're on the same page. The approach for this one I have here is the same on the. Basically, I just think about the same as when we have a sorted array, trying to remove repeated elements.
Oh, okay. So you try sorting a linked list and then remove the elements.
Yeah, the list is actually sorted. It's on the prompt. Yeah, so that's the same idea. I'm just gonna send you what I did here, but it's basically I was having a pointer, like that is for elements that are not repeated, and then another pointer to check the entire list.
Oh, you built a new list.
Yeah. Okay. But with the same references. API is saying that you should to keep the same references. So.
Okay.
I'm gonna send you. Yeah, here I have all of this.
I think okay, and yeah, you use the same amount of memory. You just have a different. You have an extra point of reference compared to EPI. That's okay. Now I understand the problem. Now I understand what you did.
Yeah, I have.
Not say bad, but.
You want me to send? I have it here. Just a minute.
Okay.
Yeah. That's it.
Okay, cool. Let's see. Let's see here. Okay, let me paste it at the top. Actually, screw it. Okay, remove duplicates from a linked list. Traverse the list while... it's... Okay, whatever. Screw it. Traverse the list. Keeping track of nodes. It's complexity. And traverse the list, keeping track of visited nodes in a set, and then create a new list. And then create a new list, and then while traversing it, if the current node not in set, just skip it. Okay. Hold up. The formatting kind of sucks ass.
I will send you with the formattation.
Yeah, just paste it. Just paste it.
Yeah.
It's too much.
Okay.
Don't send through things through Discord. Just send it. I'll put it on the Google Sheet. To be honest.
Okay, on the problem sheet. Hold up. I'll just do it. Is in the last page if you go there.
Like at the bottom, page 34.
Yeah.
Okay, I'm at the page 34. All right, let's see.
Yeah.
This one's from 3. Remove duplicates from a linked list. Traverse the list, keeping track of visited nodes in a set, and then create a new list. And then while traversing it, if the current node is not in the set, just skip it and move on. Oh.
No, that's like the most naive approach. I just write it back.
Okay. You're using too much space. You already just keep checking nodes. Skip nodes that are repeated by not considering them while traversing. How it solves the problem, because we can just reorder pointers and have end of a list only. Unique values. All right. Details. Basically have to pointer 1 being the one which... My God. Okay. I'm going to highlight this. ELI 5. I mean, like, when you do... I really want you to be critical about it. It's like, remember what I said, ELI 5, be critical about your mistakes. To me,
okay.
If this basically looks like Greek to me, it's a mistake. Let's put it that way. So...
Okay.
I mentioned this in the past, like, when, like, I'm 5, don't see if, like, a 5-year-old can understand this, but whatever. No, which will verify all nodes ahead. Once the second pointer traverses a node that differs from the first, change the reference to the first pointer next and move it to the same thing for other nodes. Okay, I get the idea. You have 2 pointers, and then the moment the second pointer finds something unique, you link it. I get it.
Yeah.
But notice like how I said it, and notice like what the fuck this is.
Yeah. I will train. I think there's like another thing we're not saying here. A language barrier. Sometimes it's hard to me to explain English, but I'll make my best.
I totally understand. Don't get me wrong. It's like at the end of the day, the interviewer himself is not going to show that much mercy either. I'm not picking on you as like a language barrier, you know. I'm picking on you because like it's like the interviewer is not gonna like give you more or less points because of the language barrier.
For sure, no, for sure. But I'm what I'm trying to say is here, like try to be more clear while expressing.
It's more simple, really. Like I would say limit your sentences to like 10 words or less.
Yeah, that's a good metric.
Yeah, just like try that. See if that works.
Okay,
and break it up into clauses. Like it's like keep it like simple. You're not writing a book. You're not writing an essay. You're just writing like a very simple step-by-step recipe, right? Like if you look at like a baking recipe, they'll say bake to 450 degrees. Yeah, and like try making it like a recipe. Maybe that helps, right?
Good.
Okay, so
I would try it.
Okay. Okay, so I think with that we actually have covered like pretty much a lot of ground. I want to say let's actually move on to like what we want to do this week. We definitely had a lot. At this point, most of the problems that you're encountering have been things that we talked about before, and it's up to you to be very, very critical of yourself on these write-ups when you do these things. It's always been pretty consistently hard for me to try and understand what you write in your practice diary. because there's no delta between what you did and what the EPI did. You need to like be a little more explicit, because otherwise I'm going to have to keep asking you, hey, show me what you did. You need to be as explicit as possible about these things. And you need to be as tough, and you need to be really, really tough about your mistakes. And I mean, like, really, like, absolutely relentless. Like, literally fear for your life if you feel like you're making the same mistake. Like, literally, oh my god, Edbert's going to yell at me again for making the exact same mistake. We've talked about this in the past, and I'm still doing it, you know? So it's the same skill I'm giving you. At this point, it's really about correcting those mistakes. Because it always keeps coming back to that. So what I want to do is actually decrease the amount of problems that you're doing and increase the amount of time you spend on it. Like, I was spend reviewing.
Okay.
Like, literally, if, like, for these blocks, let's say it takes you, if based on what I saw, it takes you, like, 40 minutes at most to do a problem, right? I literally I really want you to spend, like, for these hour-and-a-half blocks that you got going, do 2 problems, but really spend every single moment that you can going over that problem with a fine-tooth comb. And if you can't find anything else, literally just sit in your chair. And the reason why I'm making you do this is that way you're not tempted to rush to the next problem. Like, if you can, it's like, oh, this explanation can be more simple. Without losing detail or without losing the reader. Or I can rewrite this problem and or rewrite the explanations. I really want you to be obsessive. And I'm
we'll do it
about, like, correcting these mistakes and just like being absolutely focused on it. Not doing number problems, being absolutely focused on just making sure that the mistakes that we talked about in the past never happen again. Or that I can't, like, pull up your sheet and say, hey, show me the problem that you did here. I should be able to see, okay, I know exactly what you're doing. I know exactly the flow of the problem. I don't need to see anymore. It should be instantly understandable in 10 seconds.
Okay, I'll focus on that.
Yeah, so...
one question about this. For example, if I see that I write something that is nonsense, right? Like, I solved the question, but 5-year-old would not understand.
Okay.
And I just, like, just spend this 1.5 hour block just to refine the problem. I mean, like, a good amount. I'm not saying, like, 1.5 hour, but 1 hour. Just for the first ones, just to get the idea of, like, what maybe is what Edbert wants. That's what I'm trying to say here. Can I just spend more time, like, trying to be as perfect as I can?
Yeah, you should always do that, actually. Like, spend as much time as you can being as perfect as you can, because that way you don't make the same mistake. You should always be correct, like, being super obsessive about your mistakes. If you watch, like, what's it called, the way Tim Grover thinks about these things, like, when he's, like, interviewed about, like, training Michael Jordan, like, like, how obsessive he is about, like, trying to avoid mistakes. Exact same way you need to be.
Yeah, he spends, like days and days, like, trying to improve one movement. Yeah, I watched
literally,
this.
you need to be doing exactly that. And this is just for a coding interview, and there's only, like, 3 steps. It's not like an entire basketball game. This is literally just 3 things we talked about for the past, like, 2-3 weeks.
For sure.
No, it's like you're doing a whole lot less work, and it's a lot less and it's a whole lot more deterministic. So it's a lot easier to get it right. So
for sure.
No excuse here. Anyway,
I feel like, as you mentioned, I feel like sometimes, like, of course, I solve the problem, but sometimes I just rush. Okay, let's see if I improve this in the next problem. This, and sometimes it don't brings too much quality. So I'll focus on one problem at a time. And spend more time. As you mentioned.
Here's what I want you to do. Do everything. So I'm going to put this in your study plan. Do all the problems on a Google Doc, because I'm going to check every single problem that you do.
Okay.
I will check. I will check every single problem next time, and every doc needs to be perfect.
Great.
So it's like, we're gonna have a problem if it's not that. Now you don't have an excuse anymore. So when you say doc perfect, I mean everything should be explained like I'm 5. You should be able to do, and you should be able to make it easy for me to understand. You need to be able to do all the steps that we talked about, and that you need to also be, when you actually write it out when you do it the first time, you need to be as close as possible. So if, for instance, let's say you do a problem, right? And then let's say you do the doc, you edit it to be like ELI 5, etc., and it becomes vastly different than what you did in the beginning. There should be a very, very big... You should be screaming at yourself, why am I not doing this perfect thing first? Does that make sense?
Okay. Yeah, aim in the perfect Yeah. Okay.
Aim for perfect. And nothing less.
Okay. I think
Okay.
I have
and
like.
so let's see. So the problems that you actually need to do. Do you still have problems from the previous assignment that you did, or do you need to have a new set of problems?
Man, I'm just like on my, I'd say fifth problem of linked list.
Okay.
And was thinking to redo a few of the problems.
Okay.
Like from those, let me just check here. Yeah, there's like I guess 2 or 3 problems I'd like to redo. But
Okay.
if you have anything else, I don't know. It's up to you.
Let's see. So I'm giving you my advice. Search window sliding window. Go through linked list and stacks and queues. You said you're okay with stacks and queues, right?
Yeah.
Let's see. Yeah, I would say go through stacks and queues. Actually, I want to cover all our ground first. Make sure you got that going before we redo some problems. Yeah, linked list, stacks, and queues. Those should be those are the easiest ones to really come up with explanations for. So now, like, we've eliminated so many other factors, like the complexity of like recursion, all that stuff. So now you basically know there's no excuse now. So
I feel the same. When I was doing linked list problems, it was much easier for me to like follow this framework.
Yeah. Okay. So if
Yeah.
it's easier for you, then it should be easy for you to convey to me. So now, again, now you have no excuse.
Okay. No excuse. Okay.
All right. I think that's it. Going forward, basically at this point, we're just trying to reduce your mistakes. So we're gonna spend more time looking at the problems that you did, and much less time on doing newer problems, because we haven't even touched dynamic programming. Because like for dynamic programming, if you can't even do this on the basic level, then you're not gonna be able to do dynamic programming at all. So. Okay. So with that, I'm gonna let you go. Any final questions?
No questions.
All right, sounds good. Then I will let you go.
Okay. Thank you very much, man.
All right.
Bye.
All right. Bye. All right. So I guess that's it. Since there's no other questions, I see there was a lot of things in chat. So yeah. Basically, he just kept trying to over optimize way too early, and I think we talked about this in the previous coaching sessions. That he needed to get the simple solution, get the simple naive solution, and then build off that. And so this means understanding the example. I mean, I feel like part of me is like I'm just repeating myself over and over and over again. So really, I want to make sure that he's not fucking off on the practice. And I feel like, and I've had this like instinct, like, for the past 2-3 weeks, that he's been kind of fucking off on the problems. Like, oh, I'll just fix it in the next problem. Like, no, it's not. He's making the same mistake. So be absolutely relentless on your mistakes. So maybe I should enforce that much harder in the future. But I do see that everyone did try to participate in the problems that we did, which is a great sign. Thank you everyone for doing that, by the way. I really appreciate it, and I love it when people like really discuss the problems that we're doing. Because like just simply watching the stream is not enough. You have to actively try to be involved in all this and try to pretend like you're the one in the front seat. That's kind of like how you get a lot of value out of these sessions. So with that, I guess I'll let everyone go. Thank you all for joining me. We're going to have a stream next Tuesday, 8 p.m. Pacific Standard Time. So hopefully y'all join me. Hopefully you guys learned something. And good luck in your interviews. So with that, have a good day, and I'll see y'all next time.